Hi, I am Dr. Abhijit Muli, Assistant Professor from Department of Chemistry, Sadhguru Gadge Maharaj College, Kara. Spectroscopy is very important modern tool to determine structure of an organic compound. Organic chemist should possess good knowledge of spectroscopy in order to determine the structure of organic compounds. In this video, we will see what is spectroscopy, what are the advantages of spectroscopy with the conventional methods, what are some basics of spectroscopy. In first slide, I have inserted an image in which a man is focusing a torch on a sample and getting a structure on paper. Spectroscopy works similar to this picture, similar to this image, in which we are focusing electromagnetic radiations on our sample and getting information of structure of the organic molecule with help of interactions of these electromagnetic radiations with our matter, with our molecule, with our sample. Let's see what is spectroscopy. Spectroscopy, it is the study of interaction of electromagnetic radiation with matter. We are bombarding our matter with electromagnetic radiation and we are observing the interactions of these electromagnetic radiations with our matter. In this image on this slide, we have shown sun is a source of electromagnetic radiation. Our shirt is sample and our eye is detector. In day-to-day life, sun acts as source which emits electromagnetic radiations. These electromagnetic radiations hits our shirt, our sample. Some sort of radiations, some sort of interactions takes place between our sample, that is our shirt, dye in our shirt, organic molecule, and electromagnetic radiations emitted by sun. Shirt emits, our sample emits some sort of radiations and our eye detects what is the color of shirt. Pink is the color of shirt or violet is the color of shirt. This is the basic concept of spectroscopy, in which we are bombarding our sample with electromagnetic radiations and detecting what type of interactions are taking place between our sample and our source. Let's see why spectroscopy is advantageous over conventional method. In conventional method, what we are doing, if we want to determine the structure of organic molecule, we are doing its qualitative organic chemistry, organic spotting, that is preliminary test, element detection, type determination, functional group, then referring to the literature, the given compound is this one. But what is the advanced technique to determine the structure of molecule? It is spectroscopy. Let's see what are the advantages of spectroscopy over conventional method. First point is sample requirement is very small. In qualitative organic chemistry, organic spotting, we require higher quantity of sample, 4 gram, 5 gram, if you are carrying out the reaction at macro scale. But in spectroscopy, within 100 to 200 milligram, you can carry out all the UV, IR, H1 mass spectroscopy. So very much little sample is required in spectroscopy. This is the first advantage of spectroscopy. Second one is analysis is rapid and is of permanent nature. You can carry out these spectroscopies, all these 4 spectroscopic basic spectroscopies of organic chemistry within few minutes. UV within few minutes, IR within few minutes, H1, I am not saying C13, H1 PMR within few minutes, mass within few minutes. So the analysis is rapid. In conventional method, we take a lot of time to carry out the preliminary test, types, functional group test, element detection tests, a lot of tests we have to carry out and it requires a lot of time, but here the analysis is rapid. Next is methods are extremely sensitive, information obtained is accurate and highly reliable. Spectroscopies give highly accurate and reliable information. If your functional group NH2 is present in your molecule, IR spectroscopy will surely show peak of NH2. So they are accurate and we can rely on them. In conventional method, we don't rely on our experimenter, whether nitrogen is present or not. So here the method is accurate and reliable. Then next advantage is they are non-destructive, so sample can be recovered. Some molecules, some compounds, they are highly precious, they are highly costlier. In such cases we can't waste such molecules, such samples, so we have to recover the sample. In spectroscopy, these spectroscopic methods, they are non-destructive, so sample can be easily recovered. Some compounds have cost of 1 gram of compound costs about 5,000, 10,000. Such samples should be recovered, and in spectroscopy we can recover such samples. Doubtful information obtained from other sources can be quickly verified. We can quickly verify whether the structural analysis is accurate or not using the spectroscopy. So such are many more advantages of spectroscopy over the conventional methods. Thus we have to study spectroscopy seriously, and we have to know all about spectroscopy regarding the structural determination of organic molecule. Then the word electromagnetic radiation from the definition is very important. What is spectroscopy? It is study of interaction of electromagnetic radiations with matter. Then what are the electromagnetic radiations? That is the question. Electromagnetic. The word is combined with two words, electro and magnetic. Wave theory of light assumes that light wave consists of mutually perpendicular electric and magnetic fields which oscillate sinusoidally as they are propagated in space. Hence, light is called electromagnetic radiation. In light, one wave is of electric field, another wave is of magnetic field. They are perpendicular to each other and passing sinusoidally. So, for electric field, electro, and for magnetic field, magnetic, they are called as electromagnetic radiations. Now, we have to know some characteristic parameters of these light wave or electromagnetic radiation. Some basic definitions, their units, their notations. First one is wavelength. Wavelength, it is the distance between two identical points on successive trough or crust. Wavelength is distance between two identical point. Identical point is important, and successive trough or crust. Successive, I am saying that successive trough or crust. Since it is distance, its unit is nanometer, centimeter, Armstrong, that is units of distance, and it is denoted by a letter lambda, a symbol lambda. This is the basic parameter of wave. Then frequency, which is denoted by letter nu. It is number of complete cycles passing through a particular point in per unit time. In per unit time, its unit is hertz. Its unit is hertz. And how it is related with wavelength? It is inversely proportional to wavelength. As frequency increases, wavelength decreases. As frequency decreases, wavelength increases. Now, what is frequency? It is number of complete cycles passing through a particular point per second. Suppose my village is the particular point and buses are the complete cycles, and I am calculating the time, or I am taking the time per unit time as per hour. If number of buses passing through my village is high in per hour, then what I am saying, frequency of buses is high. If number of buses passing through my village is less in per hour, what I am saying, frequency of buses is less. That means my village is particular point, complete cycles is buses, and per unit time I have considered it as 1 hour. This is frequency, number of complete cycles passing through a particular point in per unit time. Then velocity of light, how it is related? C is equal to nu lambda 3.0 into 10 raised to 8 meter per second. Next parameter is wave number, which is denoted by nu bar. It is number of wavelength or cycles per centimeter. its unit is centimeter inverse. Why we have to study wave number? Because we are going to use this centimeter inverse unit in IR spectroscopy. So you should know what is the unit of wave number. It is centimeter inverse. These are the basic parameters of your wave. Then how frequency and wavelength they are related with energy, because your molecule is going to absorb energy when it is heated with electromagnetic radiation. And how energy is related? Energy is related with frequency and wavelength. Let's see. Energy is directly proportional to frequency. E is equal to h nu. That means higher the frequency, higher is the energy of wave. If frequency of your wave is high, energy is also high. If frequency of your wave is less, energy is also less, because energy is directly proportional to frequency. Next relation is energy is inversely proportional to wavelength. That means if wavelength increases, energy decreases. If wavelength decreases, energy increases. This is the relation between wavelength and energy. Energy is inversely proportional to wavelength. Energy is inversely proportional to wavelength. Now, depending upon this energy or frequency or wavelength of a light, wave or electromagnetic radiations, these electromagnetic radiations, they are divided into several small compartments, which is called electromagnetic spectrum. Depending upon energy of a wave, energy of electromagnetic radiations, in sense frequency and wavelength, the light wave is divided into several compartments called as electromagnetic spectrum. Let's see what is the electromagnetic spectrum, how the electromagnetic radiations are divided. This is the electromagnetic spectrum. From left to right, we have comparted our electromagnetic radiations in various waves. First one is radio waves, microwaves, infrared, visible, ultraviolet, X-rays and gamma rays. That means from left to right, energy increases, frequency increases, as energy is directly proportional to frequency. And from right to left, wavelength increases. That means wavelength of radio wave is much higher. You can see at the top, one wave of radio wave is as big as a soccer field or house, while that of X-ray or gamma rays, the wavelength is as much small as a water molecule. That means radio waves, they are more energetic or they are less energetic, and gamma rays, they are highly energetic, because frequency of gamma rays is higher, frequency of radio waves is smaller. Wavelength of radio wave is higher, so energy is less. Wavelength of gamma rays is smaller, so frequency is higher. Since frequency is higher, energy is also higher. Now, depending upon their energy, all these particular electromagnetic radiations, they affect on your molecule. They do something interactions depending upon their energy on your matter. Let's see what are the interactions of these each electromagnetic radiation with your matter. Starting with radio waves, they cause spin flipping. They are least energetic, so they can flip only the spin of your nucleus. Then comes microwave, they cause rotation of your molecule. Since energy increases in infrared radiation, they can vibrate your molecule. Again, going further, UV visible, they can cause electronic transition. That means they can pick up an electron from one orbital and put it in another orbital, that are called as electronic transition. Next, X-rays, they are highly energetic. They can ionize your molecule, because from left to right, energy is increasing. X-ray are highly energetic electromagnetic radiations, and they can cause ionization of your molecule, Gamma rays, they can cause nuclear changes. In nuclear chemistry, we can say alpha, beta, gamma. Gamma radiations, they cause nuclear changes. So in spectroscopy, what we are doing, we are bombarding our molecule, our matter, with all these electromagnetic radiations, and we are studying their interactions with your molecule, and on this information, obtaining this information, we are getting some sort of information regarding structure of your organic molecule. In NMR spectroscopy, we are hitting our molecule with radio waves. In infrared IR spectroscopy, we are hitting our molecule with IR. In UV visible spectroscopy, we are hitting our molecule with ultraviolet and visible radiation. Now let's see a video in which we will see how electromagnetic radiations interacts with our matter.
The IB wants you to know 3 of the many different ways that atoms and molecules can absorb energy.
Suppose this is water molecule,
so
and if we bombard this molecule with IR radiations, the molecule will
may be absorbed from the incoming energy, just like the yellow wavelength that was absorbed there. This caused the molecule to vibrate.
If
that's not the
we bombard this molecule with
it could also
microwave radiations, then it will rotate.
So electrical energy has gone into rotational energy here. And the final of the 3 ways the IB want you to know,
ultraviolet visible spectroscopy, electronic transitions takes place in which electron is shifted from one orbital to another orbital. If you bombard it with ultraviolet radiations, since these radiations are highly energetic, they cause electronic transitions. Thank you.